Ladies and gentlemen, welcome back to another video about exponent laws. Today we're going to look at one called power to a power. This is your third big exponent law after multiplication and division. Just to warn you, be very careful when you are doing this one, and we're talking about this one today. A lot of times people see this rule and they get it confused with the multiplication rule, and it ends up being an issue the whole rest of the time we talk about exponent laws. Don't let that be you. Focus on what we do today and how we discover this rule, and then focus on how this rule is different than the multiplication rule. And we'll probably have a question about that later as well. Raising powers to power. Let's use some expansion, so some of the stuff that we did before, to kind of discover this rule kind of like we did before. First off, we're going to look here and see a to the second to the fourth power. So why don't I go ahead and write out a to the second 4 times, because we know right now that that's what the fourth power means after talking and reviewing our powers and exponents and what everything is. So we go ahead and we write that out. So now I have a to the second times a to the second times a to the second times a to the second. And using my multiplication law, I actually know what this equals. I know that I add the exponents together. So really I'm just doing 2 plus 2 plus 2 plus 2. And I'm going to get a to the 8th. Now again, just kind of like we did on the other ones, I want you to see if you can make a connection from this to this. Do you see the connection between this to this? If not, just hold on. Let's do another one. A to the third, b to the second, to the third. That means we're going to take the inside here, the a to the third, b to the second, and we're going to multiply it 3 times. There's 1, there's 2, and there's 3. I know my handwriting is, once again, lovely here. So we go ahead and we write it out 3 times, and this is all multiplication, so if you're not paying attention, it's multiplication. I know it came out weird. And again, I know using my multiplication rule how I can go ahead and rewrite this. A to the third, a to the third, a to the third. I add those together. I get a to the 9th. Then I'll go ahead and add the b's together. Second, second, second. That's going to be b to the 6th. Do you see how we went from this to this? From this to this. Do you see the connection? If not, let's go ahead and let's look at another one. Here we have 2x to the third to the 5th. Again, to the 5th means we're going to write this out 5 times. So we're going to have 2x to the third times 2x to the third times 2x to the third. Just going to keep writing 2x to the third. It's going to go on forever. It's so much fun. I know you guys are all doing this with me. All right, we go ahead and we write this out. Oh man, I wrote this out a lot. I really hope I find a shortcut so I don't have to do that ever again. Well, again, I know that x to the third, I'm going to add all these exponents together. So 3 plus 3 plus 3 plus 3 plus 3, that's going to be to the 15th. And then the number part, if I can write 15, okay, the number part out front, that one I just multiply those like normal. So I do 2 times 2 times 2 times 2 times 2. Okay, so 2 times 2, that's 4, times 2 is 8, times 2 is 16, times 2 is 32. So I get 32 x to the 15th. Do you see a connection from this to this? Mainly look at the exponent part. 3 and 5, and I got 15. Let's look at the last 2 together, and then we can see if we can come up with our rule down here. 4x to the third, y to the second, or 4x to the third, y, and then the whole thing's to the second. That means I got to write this out twice, so it's 4x to the third, y, times 4x to the third, y. And again, I can go ahead and use my exponent law. Now this y, I don't see anything with it, but that means that there's a 1 hiding there. We've talked about that before. And if I add those together, I'm going to get y to the second. If I add the x exponents together, I'm going to get x to the 6th. Okay, because I'm using my multiplication law. And then I have 4 times 4, and I know that 4 times 4 is 16. Again, do you see a jump from this to this? Remembering that there is a 1 hiding here as well. Last but not least, we have 3 to the second, x, y to the 4th. So that, or to x, y to the 4th, and all that's to the 3rd. So we're going to write 3 to the second, x, y to the 4th, times 3 to the second, x, y to the 4th, times 3 to the second, x, y to the 4th. And then when I look at this, all right, let's go ahead, let's combine these together. So at y to the fourth, y to the fourth, y to the fourth, that's going to be y to the 12th. These x's all have 1s hiding with them. I can go ahead and write those in if I want to. So that's going to be x to the 3rd. And then for the 3, I can really look at the exponents and kind of use our multiplication law here. I have 2, 2, and 2. So really I have 3 to the 6th. Now, if I want to simplify this a little bit more, I can go ahead and write what 3 to the 6th equals, which is 729, and then rewrite the x to the 3rd, y to the 12th. Okay. All right, so we have that there. All right, cool. We're good to go here. Let's figure out this power. Hopefully you notice, especially the first one can really help you see it, that we are actually multiplying these exponents. That's going to be our shortcut. So when we multiplied powers together, we added their exponents. When we raise them to a power, when we see a power to a power, we're going to multiply their exponents. And that's where some of that confusion comes in. So to raise a power to a power, you're going to multiply the exponents. You're going to multiply the exponents. And again, we said that is different than our multiplication rule. Our multiplication rule is when we're multiplying powers, we add the exponents. When we raise it to a power, we'll multiply the exponents. So in this case, I see 2 to the 2nd to the 4th. It's going to be 3 to the 8th. I multiply the exponents. And then over here, if I want to look at the generic version, it's going to be a to the m times n. I'm going to multiply the exponents. That's going to be our shortcut. All right, so down here is what I want you to do. I want you to go ahead and pause the video for a moment. I want you to try each of these, okay? So try A, B, C, and D. And then after you do those, unpause the video and check for my solutions here. You can go ahead and check for my solutions, and we'll talk about how this law works. And then we'll kind of talk a little bit about the difference between this and the multiplication rule, just to make sure that we're okay with that. But for right now, pause the video, do A, B, C, and D, then unpause it, and go ahead and check with me. Hopefully you went ahead and did these problems on your own, and now you're coming back and checking with me. If you go ahead and look at this first one, again, I'm going to multiply the exponents because this is a power to a power. 4 times 6 gives me 24, and 3 times 6 gives me 18. For B, I remembered that the 3 and the x have a 1 exponent that's hiding there, so I'll multiply those by the 2. I get 3 to the 2nd, x to the 2nd, y to the 10th, and then because 3 is a number base, I can go ahead and figure out what that equals and get 9, because that's what 3 squared is. Down here for C, I have 4 to the 2nd to the 3rd, so it's going to be 4 to the 6th, x to the 12th, y to the 9th, and again, 4 to the 6th is 4096, so I can simplify that a little bit further. And then last but not least, over here, again, I remember that the C has a 1 with it. Multiply these, A to the 30th, B to the 15th, C to the 5th. So when you have a power to a power, you are multiplying the exponents. Now, just to make sure that we are on the same page about how these are connected, if you have something like this, let's say x to the 5th times x to the 3rd, that is a multiplication rule. Do you see how these two powers are being multiplied? That is a problem that you would add them together and get x to the 8th. That is different than when you do a power to a power, such as x to the 5th raised to the 3rd. When that's the case, this is when you multiply the exponents and you get x to the 15th. So when I multiply the powers, I add them and get 8. When I take it to the power, I multiply and get 15. Now, there is a trick to help you remember this if you get confused by this. So make sure you write this trick down at the bottom of your paper here, okay? Remember how we keep writing, please excuse my dear Aunt Sally. We always do it this way to help remember when things happen, right? I always say, instead of please excuse my dear Aunt Sally, I would say as. That way remember that multiplication, division, addition, subtraction happen at the same time. Now, Mr. Conway has a trick, if anybody of you guys have Mr. Conway, called Under Aunt Sally, where he goes ahead and he uses this to help him remember what exponent laws happen. When you are multiplying two powers together, you are going to add the exponents. See how it's underneath the m? And when you go to divide two powers, you're going to subtract the exponents. Do you see us underneath the D? And then this one, we are taking an exponent to an exponent, so we are going to multiply the exponents. Okay? He calls it under Aunt Sally. If that's a trick that helps you, please write that down in your paper and have that used there to remind you. The big thing to make sure is that you do not get confused with the multiplication rule and the power to a power rule, the exponent rule. Okay? These are very different problems. This problem right here and this problem right here are very, very different. Okay? All right, well, thank you guys for watching, and make sure you answer the questions to follow this.